This is lesson from March 30th. This is part 3. Symmetric equation. We just worked it out. We know it's going to be x minus x ought over a equals y minus y ought over b equals z minus z ought over c. X ought, y ought, z ought are some point that you're given. A, b, and c are from the direction vector. That's what we're given. So if I'm given this particular point, I have points on them. I can use either one for x ought, y ought, or z ought, but I need the direction vector. I need to figure it out. So I need to figure out AB, which is going to be 3 minus a negative 1, 4. Negative 4, 9, 8 minus 7, 1. So I will get something like that. Okay. Easy enough. Now, to get a symmetric equation, I'm going to get x minus 4 or if I want, let's do it a bit more basically. I can build an equation now. I can build x, y, z equals, pick one of these two, pick the first one, negative 1, 5, 7 plus k 4, negative 9, 1. The parametric equations will be x equals negative 1 plus 4k, y equals 5 minus 9k, z equals 7 plus k. Rewrite them. X plus 1 divided by 4 equals k. Y minus 5 divided by negative 9 equals k. Z minus 7 divided by 1 equals k. Therefore, the parametric is x plus 1 over 4 equals y minus 5 over negative 9 equals z minus 7 over 1. There is the symmetric. So, if I do the same thing with this one, I'm going to get PQ. And I will get 4 minus negative 2, 6. 3 minus 3 is 0. Negative 5 minus 1 is negative 6. Now, another thing we should notice is we could reduce this one to 1, 0, negative 1. Or negative 1, 0, 1. It's fine. All right. Now we can do this a bit faster than going the whole route. I know a point and I know this. So the parametric is going to be x, change the sign, plus 2 divided by 1 equals y, change the sign, divided by the slope, equals z, change the sign, divided by the slope, negative 1. There's a parametric, but we have a bit of an issue. This comes up every once in a while. You cannot divide by 0. So you're going to get x plus 2 divided by 1 equals z minus 1 divided by negative 1, comma. No matter what happens in this particular question, y must be 3. And then therefore, that would be my parametric, my symmetric. When that occurs, we end up with this. It could be either letter. It could be x, y, or z. That's 6. Okay, so the last page, I believe. Page number 7. Find a symmetric equation using these points. All right, well, it's just more of the same, I think. xy will be negative 1 minus negative 1, which is 0. 3 minus 2 is 1. 9 minus 5 is 4. Or 0, negative 1, negative 4. If you do it the other way around, it makes no difference. So, You can use this point or this point. It doesn't matter. Now, but you have to sort of change the sign. I could go x plus 1 divided by 0 equals y minus 2 divided by 1 equals z minus 5 divided by 4. But already, from the previous question, I know I can't do this. So my answer is going to be y minus 2 divided by 1 equals z minus 5 over 4, comma, x must be -1. There is my symmetric equation for this particular system. There is some homework. And we are done for today.